You know that feeling, right? You pop on a pair of headphones and suddenly the whole world just fades away. That crazy sudden quiet you get on a noisy airplane or in a packed coffee shop? Well, today, we're going to pull back the curtain on the science behind that little piece of magic: noise cancellation. All right, so let's just start with the question that sounds like it breaks the laws of physics. How in the world can you add more sound to a situation and end up with less sound? It feels totally backward, kind of like trying to dry yourself off by jumping in a pool. But believe it or not, cracking this puzzle is the key to understanding the entire technology. So the answer isn't magic. It's actually just some really, really clever audio engineering. We're going to start with the core principle behind it all, a method called active noise control, or ANC for short. So here it is, the official definition. Active noise control is all about fighting fire with fire, or, in this case, fighting sound with sound. It doesn't just muffle noise, no. It actively creates a brand new sound, a special sound that is specifically designed to completely wipe out the original. The key thing to get here is that it's an additive process that gives you a subtractive result. Wild, right? But before we can really wrap our heads around how you can just erase a sound wave, we need to take a quick step back and ask a simple question. What is sound, anyway? I mean, we can't see it, but it's a very real, physical thing. When you get right down to it, sound is just an invisible wave of pressure moving through the air. Think about ripples spreading out in a pond. It's basically that. A sound wave has peaks, which are little pockets of high pressure, and it has valleys, which are pockets of low pressure. And it's that repeating up and down pattern that our eardrums pick up and our brains translate into sound. Okay, so we've established that sound is just a wave. It has peaks, it has valleys. Now that we've got that down, we can get to the really cool part, the aha moment. This is how you use one wave to completely annihilate another one. So look at this. This little diagram explains the entire trick. That red wave, let's say that's the annoying drone of a jet engine. Your headphones then create that blue wave, the anti-noise, which is a perfect, exact mirror image of the red one. See how the peak of the red wave lines up perfectly with the valley of the blue one? Well, when those two waves meet in the air, they completely cancel each other out, creating that flat line you see on the right. And a flat line is silence. That's what's called destructive interference. Yeah, this is honestly the best way to think about it. The technology isn't just blocking the noise, it's actively erasing it by creating its evil twin, its perfect opposite. It's like an audio anti-hero. So you're probably wondering, how on earth does all this happen inside your headphones in the blink of an eye? Well, it's basically a super fast three-step dance. First, a tiny little microphone on the outside of your headphones listens to the noise around you. Second, a powerful little computer chip inside instantly analyzes that noise and creates its perfect opposite, the anti-noise wave. And third, a speaker inside your headphones plays that anti-noise into your ear at the exact same moment as the real noise. And poof, they cancel each other out. Now, this all feels incredibly modern, like something out of a sci-fi movie. But you'd be surprised. The basic idea has actually been around for a really long time. Let's take a look at how we got from a patent in the 1930s to the earbuds in our pockets today. Get this. The original patent for this idea was filed all the way back in 1936. By the 1950s, engineers were developing early versions to help pilots deal with the deafening roar inside airplane cockpits. But it really wasn't until the 1980s that the electronics got small enough and powerful enough to fit into the first commercial headsets, which were, you guessed it, made for airline passengers. And if we fast forward to today, this technology is absolutely everywhere. I mean, of course, it's in our headphones and our earbuds, but it's also in our smartphones, helping to isolate our voice from background noise during a call. Car makers are even using it to make cabins quieter and to build more efficient engines. Okay, but as amazing as active noise control is, and it is amazing, it's not a magical mute button for the entire world. It has some very specific limits, which is exactly why your headphones are great at blocking out an engine, but not so great at blocking out the person talking right next to you. So the first big issue is scale. ANC works brilliantly in what we call a one-dimensional zone. Think about that tiny, predictable little pocket of air between the headphone speaker and your eardrum. That's a super easy target to hit. But trying to cancel out all the noise in a big three-dimensional space, like your entire living room, well, that is incredibly difficult. You'd need a whole network of microphones and speakers, and you could even end up creating hotspots where you accidentally make the noise twice as loud. Oops. And the other major limitation is the type of sound. ANC is an absolute master at getting rid of low-frequency, constant droning noises. Like the hum of an engine or the buzz of an air conditioner. Those waves are simple. They're steady, they're predictable. But high-frequency sounds, things that are sudden and complex, like a siren, a dog barking, or somebody's voice, they're just too fast and chaotic for the system to keep up with. And check this out. Here's a really weird quirk of the physics. Around a frequency of 800 hertz, a sound coming from your side can create a bizarre problem. The system might perfectly cancel the noise in the ear closest to the sound, but the anti-noise wave arrives at your other ear at just the wrong moment, and it actually ends up doubling the volume of the sound. So strange. So if active noise control is really only good for those low, rumbly sounds, how do our headphones give us that feeling of being in a total bubble of silence? Well, that's because there's another player in this game. ANC isn't working alone.
It's really a partnership. On one side, you have the high-tech active noise control, the electronics creating that anti-noise wave to kill the low frequencies. But on the other side, you have good old passive noise control. This is just basic physics, using physical materials like dense foam and a good tight seal to physically block sound waves from ever reaching your ear. And this physical barrier is what's really, really good at blocking those high-frequency sounds that ANC struggles with.
And that right there is the secret sauce. The best noise-canceling gear doesn't make you choose. It uses both. It's a team effort. The physical design, the passive part, acts as a shield against those sharp, high-pitched noises. Meanwhile, the active electronics are busy erasing all that low-end rumble. It's the combination of the two that creates that incredible quiet. So from a simple idea in a 1930s patent to a device that can literally erase the drone of the world around us, the human quest for a little peace and quiet is pretty amazing. And it makes you wonder, right? In a world that just keeps getting louder and louder, what's next? What's the next frontier for silence? Are we going to move beyond just personal quiet zones and start creating truly quiet public spaces with just the flip of a switch? It's a pretty cool thing to think about.